Okay, next is the introduction to the energy loss in the pipe. Okay, from the general energy equation, we learn about the energy loss in the system. So when we consider the energy loss in the system, they have two type of the energy loss. Okay, first is we call as major loss. Okay, first is the major loss, and the second one is the minor loss. So basically, the major loss they come from the viscous effect in the straight pipe. So basically, the energy loss takes place continuously along the path of flow. So we also call as energy loss due to friction occur in the pipe. Major loss, they also relate with the type of material of pipe we use in the system. Okay, and then the second is the minor loss, or we call as HL minor. And this minor loss is occur due to viscous effect in the pipe component. For example, we install component like fitting, valve, entrance, exit pipe. So this component will contribute to the minor loss to the pipe system analysis. So basically, this loss generally created by increased turbulence and resistance to flow at point in the stream where the direction of flow is changed or where other obstruction take place in our pipeline system. Okay, so how to calculate the major energy loss in the system or the energy loss due to friction? So basically, we have two equations that we can use to calculate the energy loss due to friction or major loss. First, we can use the Hagen-Poisson equation. First, you can use the Hagen equation, and the second can use the Darcy equation. Okay, for the Hagen-Poisson equation, you can refer this equation. So the formula is HL is equal to 32 time with the dynamic viscosity, time with the total length of pipe, and time with the velocity of flow. And then divide by the density of fluid, time with the gravity, and time with the diameter of pipe square. But the limitation of this equation is only valid for the laminar flow, which is the Reynolds number is less than 2000. So that means this equation only can be used for the laminar flow lah. So how about the turbulent flow? So let's say the Reynolds number is greater than 4000. So for the turbulent flow, we need to use the Darcy equation. So this is the equation for the Darcy equation, which is the HL, the energy loss, is equal to the friction factor time with L, the total length of the pipe, and then divide by the diameter of pipe, and then time with the velocity square over 2g. Okay, so this equation we can use to calculate the energy loss in the pipe for the turbulent flow, and also we can use this equation for laminar flow. For laminar and also for turbulent flow. Okay, so the difference is between laminar and also turbulent is the friction number here, the F value here. Okay, so the difference for the Darcy equation is the F value. So how to get this F value? Okay, so for the laminar flow, we can get the value of friction factor from this equation. So the friction factor is equal to 64 over Reynolds number. So this one is only valid for the Reynolds number is less than 2000. But for the turbulent flow, which is the Reynolds number is greater than 4000, so we need to use Moody chart. And also this Moody chart is depend on the Reynolds number and also the relative roughness of the pipe. Okay, now we go for example for major energy loss due to friction in laminar flow. So look for the example. Okay, determine the energy loss if glycerin at 25 degrees Celsius uh, with the density of glycerin is 1258 kilogram per meter cube, and the dynamic viscosity is 9.6 times 10 negative 1 kilogram per meter second. Flow 30 meter through a 150 mm diameter pipes with an average velocity of 4 meter per second. Okay, so first we list up all the information for this question. So for this question, we have the density of glycerin, which is 1258 kilogram per meter cube. Then we have dynamic viscosity, which is 9.6 times 10 negative 1 kilogram per meter second. And the total length of pipe is, which is L, is equal to 30 meter. And then we have the diameter of pipe. Diameter of pipe is 150 mm. So we convert to meter. So we get 0.15 meter. And then the velocity of flow is 4 meter per second. Before we calculate the energy loss in the pipe, so we need to know either the flow is laminar or turbulent flow, because every flow they have a different equation and also different method to determine the friction factor, the F value. So first we determine the flow using the Reynolds number. Okay, so this the formula to determine the Reynolds number. So RE is equal to density time with the velocity of flow, and then time with the diameter of pipe, and divide to dynamic viscosity. So we substitute all this information into this Reynolds number equation. So the density is 1258 kilogram per meter cube, and time with the velocity of flow in the pipe, which is 4 meter per second, and then time with the diameter of pipe, which is 0.15 meter, and divide with dynamic viscosity 9.6 times 10 negative 1 kilogram per meter second. So when we calculate the Reynolds number, we get the value is 786. Okay, so this value is below than 2000. So mean the flow is laminar flow. Okay, so now because the flow is laminar, so we have two equations to determine the energy loss. First, we can use the Darcy equation, and the second one we can use the Hagen equation. Okay, let's say we choose the Darcy equation to determine the energy loss in the pipe. Okay, so this is the Darcy equation to determine the energy loss in the pipe. So the HL is equal to F, the friction factor, and then time with L, the total length of pipe, and then we divide to the diameter of pipe, and then time with velocity of flow square over 2 times gravity. Okay, first, before we can solve this equation, we need to determine the friction factor. Okay, so because the flow is laminar, and we know to calculate the friction factor here, F is equal to 64 over RE. Okay, so when we calculate the friction factor for laminar flow, so we get 64 over Renat number, and the Renat number is 786. So when we calculate, we get the friction factor is 0.081. Okay, now we solve this equation because we already know all the information. Okay, we substitute the value for the friction factor, which is equal to 0.081, and then time with the total length of pipe, which is 30 meter, and then we divide to the diameter of pipe, 0.15 meter, and then we time with the velocity of flow in the pipe, which is 4 meter per second, and then we square, divide by 2 times gravity. So when we calculate, we get the value for the energy loss in the pipe is 13.2 meter. So this by using the Darcy equation. Okay, next we also try to use the Hagen equation to calculate the energy loss in the pipe. So we use the Hagen equation. Okay, so this is the formula for Hagen equation to determine the energy loss in the pipe. So HL is equal to 32 time with the dynamic viscosity, and then time with the total length of pipe, and then time with velocity of flow, and we divide to the density of fluid, or in this case is glycerin, and then time with the gravity, and then time with the diameter of pipe square. Okay, then we solve the equation. We substitute the value for the dynamic viscosity, 9.6 times 10 negative 1 kilogram per meter second, and time with the total length of pipe, which is 30 meter, and time with the velocity of flow in the pipe, 4 meter per second, and divide to the density of glycerin, and time with the gravity, and time with the diameter of pipe, which is 0.15 meter square. So when we calculate the energy loss using the Hagen equation, we get the value for the energy loss is 13.3 meter. So from this value, we know that about 13.3 Newton meter of energy is lost by each Newton of the glycerin as it flows along the 30 meter of pipe. Okay, now we go for the second example for the major energy loss due to friction in laminar flow. So refer to the question. water at a dynamic viscosity of 1.14 times 10 negative 3 kilogram per meter second and density of 998 kilogram per meter cube flow in a horizontal pipe uh, with 85 meter long with a diameter of 5 mm. So if the flow rate is 25 liter per hour, determine the pressure drop in the pipe. Okay, so before we solve this problem, um, we need to convert the unit for the flow rate, which is in this question in liter per hour. So we need to convert the flow rate from liter per hour to meter cube per second. So how to convert? So from this liter per hour, we need to convert to meter cube per second. And we know 1 meter cube is equal to 1000 liter and 1 hour is equal to 60 minutes and 1 minute is equal to 60 seconds. Okay, so when we convert, we get the flow rate is 6.94 times 10 negative 6 meter cube per second. Now we calculate the cross-sectional area of the pipe. Okay, because the pipe is circular pipe, so we can use the formula for circular pipe is pi times diameter square over 4. And when we calculate, we get the cross-sectional area of the pipe is 1.963 times 10 negative 5 meter square. So we already calculate the area and then we need to calculate the velocity in the pipe. So we can use the equation Q is equal to AV, area times velocity. So the velocity is equal to flow rate divided by area. So flow rate divided by area. So when we calculate, the flow rate is 6.94 times 10 negative 6 meter cube per second, and we divide to the area of the pipe, 1.963 times 10 negative 5 meter square. So we get the velocity in the pipe is 0.354 meter per second. So then because we need to identify first either the flow is laminar or turbulent, so we need to use Reynolds number. Okay, so we use the formula to calculate the Reynolds number here, which is the Reynolds number is equal to density time with the velocity and then time with the diameter of pipe and divide with dynamic viscosity. Okay, we substitute the value for the density of water, which is 998 kilogram per meter cube, and then time with the velocity 0.354 meter per second, and time with the diameter of pipe 0.005 meter, and divide to the dynamic viscosity of water, which is 1.14 times 10 negative 3 kilogram per meter second. So when we calculate, the Reynolds number is 1550. So this value is less than 2000. So mean the flow is laminar flow. Okay. Okay. Then because the question we need to calculate the pressure drop between 2 points in the pipe. So mean we need to determine the pressure difference between 2 points in the pipe. So we draw the pipe. Okay, so let's say this is our pipe. Okay, and water will flow from point 1, let's say point 1, this is the point 1 to point 2. So this is the flow of water direction. And this pipe, the diameter of pipe is the D is 0.005 meter. Okay, and from the question we know that the distance of this water flow from this point 1 to point 2 is 85 meter. So the distance from this point 1 to point 2, the total length is 85 meter. Okay. So now we write the energy equation between these 2 points, point 1 and point 2. Okay, so this is our energy equation for point 1 and also for point 2. Okay, from this energy equation, there are several terms we can cancel out. So if we look at this pipe, we know that when water flow from this point 1 to point 2, there are no changes in terms of the size or the diameter of pipe. So mean the diameter for pipe 1 is equal to the diameter for pipe 2. So from this information, we know that this pipe have the same velocity. Mean the velocity at this point 1 is the same with the velocity at this point 2. So V1 is equal to V2. So if we refer to this energy equation, we can cancel out the velocity head term for this point 1 and also for this velocity head term for this point 2. Okay, next, if we refer to the question or this pipe, there are no pump and also motor installed in this pipe. So mean there are no energy added. So we can cancel this HA. Okay, and also there are no energy removed. So mean the HR is equal to 0. So we can say the HA and also HR is equal to 0. Okay, then because this pipe is horizontal pipe, so mean the Z1 is equal to Z2. So from this energy equation, we can cancel out the Z1 here and also the Z2. Okay, so then when we rearrange this equation, we get this new equation for our energy equation. So P1 over rho G minus P2 over rho G is equal to HL, or our energy loss. Okay, so because the question asks to calculate the pressure drop, which is this pressure drop is equal to P1 minus P2. So when we rearrange this equation, we get P1 minus P2 is equal to rho GHL. Okay, then because the flow is laminar, so mean we can use the Hagen equation, and also we can use the Darcy equation to calculate the energy loss. The HL here. Okay, let's say for this example, we use the Hagen equation to determine the energy loss, or HL. So from the Hagen equation, we know that the HL, or energy loss, is equal to 32 times the dynamic viscosity time with the total length of pipe, and then time with the velocity of flow, and divide to the density of water, time with the gravity, and time with the diameter of pipe square. So when we substitute all the information, we get the energy loss in this pipe is about 4.485 meter. So this is the value for our HL, or energy loss in the pipe. Okay, now we already solved for the HL. So then we can calculate or determine the pressure drop between 2 points in this pipe. So this is the formula we already create from the energy equation. So the pressure drop is equal to P1 minus P2 is the pressure drop. The difference between the pressure between point 1 and also the pressure at point 2, which is equal to the density time with gravity time energy loss. So when we substitute the density of water, which is 998 kilogram per meter cube, then time with the gravity, and then we time with the HL, energy loss in the pipe, which is 4.485 meter, and this is our conversion unit, also this one. So when we calculate, we get the pressure drop between 2 points in the pipe, or the difference between pressure at point 1 and point 2 in the pipe is about 43.91 kilopascal. So this is the answer for this question.